Okay, finite math students, this is going to be my first video on the Chapter 6 homework. Unfortunately, it's going to be a short video. I don't have a lot of time this afternoon. We're just going to work on, let's say, 3 or 4 problems, and hopefully we'll have enough time for that. Okay, so let's start looking at problem number 1. Number 1 in your Chapter 6 homework. Excuse me. In how many ways can two variables be chosen from x1, x2, s1, s2, and assigned the value 0? So this is really a combination type of problem. 1 second. There's some dirt on my computer. 1 second. Okay. I'm just cleaning my computer screen over here. Okay. So anyway, this is a combination problem. It's a combination problem. So if you have 4 things, x1, x2, s1, s2, how many ways can 2 variables be chosen from that? And order doesn't make a difference. Order does not make a difference. That's very easy to do. Just use the binomial command. Use the binomial command in Mathematica. And we have 6. There are 6 possibilities. There are 6 possible combinations. There are 6 ways. That should be correct. Okay, very simple. Just one command. Just one command. So what are the different possibilities? Let me try to well, see, if you do permutations, you're not going to get the right answer because S1, S2, and the answer would, okay, I'm looking for two arrangements of 4 things. Okay, but this is going to be greater than 6 because here the order makes a difference. So for example, you have x1 and x2. Let me see. You have x1 and x2, and here you have x2 and x1. So for example, this is a permutation, but notice you have x1 and x2 is right over here, and then here you have x2, x1. And they are counted separately, whereas in a combination, they are counted once because the order doesn't make a difference. So this would not work. This would not give you the right answer. However, this will give you the right answer. It will not enumerate all the different combinations for you, but it will tell you how many different combinations you have. Okay? But let's not worry too much about this problem. So I showed you the way to get the answer, but I don't want to dwell on this one problem for too long because there are problems in this chapter that are much more challenging than this one problem that we just went over. Okay? All right. A student in the class asked me about problem number 39. So let's take a look at 39. Oh, by the way, if you do look at this list, how many elements do you have in the list? Well, let's see. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And that's fine, but it might be easier. You have 12 elements. It might be easier if you simply do this. Length. The length of the last answer is 12. So learn to use Mathematica. It is really not that difficult. Okay, a student in the class asked me about problem number 39. Let's look at problem 39. Okay, so using slack variables, determine the initial system for the linear programming problem. That's part A. And part B is write the simplex tableau and identify the first pivot and the entering and exiting variables. Part C, use the simplex method to solve the problem. Okay, so the first constraint is 4x1 plus, oh, wait one moment. Let me read the rest of this. Yeah, S1, S2 greater than, okay, they want us to use S1 and S2 for the slack variables. So 4x1 plus x2 plus slack variable 1 is equal to 12. The second constraint will be x1 plus 8x2 plus the second slack variable is equal to 12. The objective function is going to be, right over here, negative 28x1. Notice that these variables right here are going to be put on the other side of the equal sign, and that's why their signs are going to have to change. Okay, the negatives become positives and the positives become negatives, right? Okay, so that's negative 28x1, minus x2 plus p is equal to 0. Although, you know what? I have a feeling, well, that's the way you would enter that into the matrix, but I have a feeling what they want, let me see, what they want is probably p is equal to 28 x1 plus x2. But the way that I did it before is the way you would enter that row into your matrix. Okay, so let's check the answer. Okay, that's the answer they want. Okay. Write the simplex tableau by filling in the blanks below. Well, that's going to be easy. We're going to have 4, and then 1, and then 1, 0. And this is going to be 1, and then 8, 0, 1, 0. So this is just, that should be a 0, not a 9. This is just the identity matrix. And then here we're going to have negative 28x1, and then negative 1x2, and this is 0, 0, 1, and then of course we have 0. Okay, so let's build this in Mathematica. Okay. So what should I call it? I'm going to call it matrix A, 4, 1. The identity matrix, you know what, I'm going to add that separately. So notice what's going on here. My slack variables are actually represented by, my slack variable 1, slack variable 2, and the P usually stands for profit. That's going to be represented by a 3 by 3 identity matrix, okay? So then we have 4, 1, 1, 8, negative 28, negative 1, matrix form. Okay, so what does the 3 by 3 identity matrix look like? Well, if you did the chapter 4 homework, you should know that. Okay, the identity matrix with 3 rows and 3 columns is going to look like this. And that's what I'm going to have to choose because I have 3 rows in matrix A. All right, so my new A, I'm going to join some matrices here. Identity matrix 3. And then that last column of 12, 12, 0. Oh, wait a second, sorry. I need to put the number 2. And the reason I'm putting in the number 2 is because I'm not just joining lists, I'm joining matrices. Matrices, a matrix in Mathematica is a list of lists. It's a list where each row of the matrix is represented as a list. So therefore you're dealing with nested lists, and that's why I need to use that number 2. So let's see what this looks like. Okay, so that looks good. Let's see. Hold on one second. Check answer. That is correct. Okay, the pivot element is located in the, so we look over here at the bottom row. What is the most negative element in the bottom row? It's negative 28. Okay, so this is going to be the pivot column. And then we take the ratios. 12 divided by 4 is equal to 3. And then 12 divided by 1 is equal to 12. Oop. So we have 3 is less than 12. Is that not so? So that means I'm going to have to pivot right over here. All right, I'm going to have to pivot right over there. So the pivot element is located in the x1 column and the s1 row. The entering variable is x1, that's the column variable, and the exiting variable is the row variable, which is going to be s1. Okay, so then we just have to figure out the solution to the problem. All right, so here we go. We're going to pivot right over here. Okay. Okay, so what that means, guys, is I'm going to transform this matrix. I'm going to transform this matrix so that the first column, or my x1 column, looks like this: 1, 0, 0. And then this is a bunch of other stuff, a bunch of numbers, right? Okay. So the first row of matrix A is 1 over 4 times the first row of matrix A. Okay. And then the second row of matrix A is the second row minus the first row, and that's going to look like that. All right, and then the third row of matrix A is going to be the third row plus 28 times the first row, and there we go. There we have it. And now we know we're finished, because are any of these numbers negative? Are any of these numbers negative? So these numbers here definitely should not be negative. If you have, if these numbers are negative, if those numbers are negative, you really made a mistake. Okay, that's not good. Okay, they can be 0, but they can't be negative. Are any of these numbers negative? Because if they are, you have to repeat the algorithm. And if they are not, then you're finished with the problem. So the answer is going to be x1 is equal to 3. So this is the x1 column, and it's a basic column because we just have 1 and zeros. So that answer is 3, right? And then x2 is a non-basic column, and if it's a non-basic column, that means the value has to be 0. It has to be 0, And then P is going to be 84. And that's it. That's actually going to be the correct answer. So, 1 second. Let me, okay. Okay, so the maximum value is P is 84 when x1 is equal to 3 and x2 is equal to 0. Check answer. Okay, that should be correct. And see, that wasn't even that difficult. Okay, let me check the time because we don't have a lot of time, unfortunately, today. I have a lot going on today, but I will try to do another one of these videos for you. I will do another one of these videos for you guys over the weekend. It will be a longer video covering more of these problems, okay? But right now, guys, I just don't have a lot of time. So we have time for one more of these problems, okay? Just one more problem, and that's going to be it. Let's see. Let's do something kind of interesting, but I'd like to do a word problem. Where are the word problems? Okay, I don't see word problems here. Well, okay, okay, the word problems I think are later on in your homework. That's okay. Okay, let's do number 47, although I have a feeling this one is going to take some time, but that's okay. Okay. So the problem reads, maximize z is equal to 300x1 plus 200x2 plus 100x3, subject to the constraints or restrictions x1 plus x2 plus x3 is less than or equal to 110, 2x1 plus 3x2 plus 4x3 is less than or equal to 300, and then 2x1 plus x2 plus x3 is less than or equal to 180. And of course, guys, these are almost always true. In this class, they will always be true. In this class, they will always be true. The variables are not going to be negative. In this class, in a more advanced class, that restriction does not necessarily apply. However, in this class, you know, x1, x2, x3, x4, x5, whatever, however many variables you have, they will always be greater than or equal to 0. They will not be negative. Okay, which is normally the case anyway in real world applications, okay? So let's build our matrix. Let's build our matrix. So clear A, let's start over with a brand new A. A is equal to, okay, look at the numbers in front of my variables. Look at the coefficients of my variables, okay? 1, 1, 1, 2, 3, 4, 2, 1, 1. And then I need to reverse the signs of the coefficients of the objective function. What are the coefficients of the objective function? 300, 200, 100. They're all positive in this case. I need to reverse those signs, right? So it's going to be negative 300, negative 200, negative 100. Okay, fabulous. So let's make sure everything looks okay. Okay. Let's see. 1, 1, 1, 2, 3, 4, 2, 1, 1, negative 300, negative 200, negative 100. Fabulous. So how many rows do I have? Well, now I'm going to add the slack variables. So I have 1, 2, 3, 4, right? So my matrix has 4 rows, okay? Which means I need to use the 4x4 identity matrix to represent the slack variables, okay? So let's see, how am I going to do that in Mathematica? Join A, okay, identity matrix 4. And then add the numbers all the way on the right. 110, 300, 180. And of course, we almost always have 0 at the very bottom. And don't forget that number 2, because we're dealing with a matrix and not just a regular list, okay? Matrix form. Now, where should we start to pivot? Well, the pivot column usually is the column that has the most negative number in the bottom row. So therefore, this is going to be our pivot column. Okay, what's the pivot row? Let's see. 110 divided by 1 is 100. Wait a minute. 110. It's a little hard to write with this this marker. 300 divided by 2. What's 300 divided by 2? That's going to give us 150. And then what's 180 divided by 2? That's going to be 90. Now, okay, so of those 3 values, of those 3 ratios, which one is the smallest? It's this one. It's going to be this one. So this is going to be the pivot element. This is going to be the pivot element. Trust me, you will know if you pick the wrong pivot element, because if you pick the wrong pivot element, you're going to end up with negative numbers on the right-hand side. You're going to end up with negative numbers all the way in the rightmost column of your matrix, and that's really bad. That's really bad because we can see here that all of your variables are supposed to be greater than or equal to 0, right? You can't have negative values. You can have 0, but you can't have negative values in the rightmost column of your matrix. Okay, so we're going to have to start pivoting right over there. So how do we do that? Third row is equal to 1/2 times the third row. This is just, Gaussian elimination from chapter 4. You guys should know this already, I hope. Okay, so now this is a 1, and remember, all these other values become 0. Okay, so the first row is equal to the first row minus the third row. All right, matrix form, okay. And then the second row, how are we changing the second row? The new second row is equal to the old second row minus 2 times the third row. So notice I keep referring back to the row that contains that initial magical 1, okay? And then here, how do I get rid of that negative 300 and turn it into a 0? Fourth row is equal to the fourth row plus 300 times the third row. Oops. And there you go. Everything looks good, except I can see there's a negative value right over here, which means I'm not done with the simplex algorithm. I have to continue using the algorithm until I've used up all the negative numbers right over here. You're not going to worry about the 1 here. That's never going to be negative. And don't worry about this value over here. Actually, that value could be negative in some problems. Usually it isn't, but it can be, but we're not going to worry about it. We're just worried about these numbers right over here, okay? I still see a negative value here, so where am I supposed to pivot? Well, 20 divided by 1/2 is 40, okay? 120 divided by 2 is 60. And 90 divided by 1/2, excuse me, 90 divided by 1/2 is 180. Okay, so the minimum of those 3 numbers is 40. So we have to pivot right over there. Okay, so let's go for it. Okay, there we go. So let's start. I'm changing the first row. How am I doing that? Multiply by the reciprocal of the number I'm pivoting on. So 2 times the first row of matrix A matrix form. Okay, fabulous. Change this 2 into a 0. All these numbers here. Okay, 1 second. All these numbers here have to get turned into zeros, yes? Okay, so then the second row is equal to the second row minus 2 times the first row. Matrix form, okay. Do the same with the third row. The third row is equal to the third row minus 1/2 times the first row. Okay, and then finally the fourth row, which contains that negative 50 that we want to get rid of, is going to be the fourth row plus 50 times the first row. Okay, so now you got to ask yourself, look at the bottom row. Look at the bottom row. Is anything negative over here? No, I see 0, 0, 100, 100, 0, 100. Everything is 0 or positive. Yay, so we can celebrate. We're done with the problem. We're done with the problem. So that means, 1 second, let me get rid of that. Okay, so the maximum value is going to be, how do I read the maximum value? Well, this is the x1 column. This is the x2 column. This is the x3 column, right? These are your slack variables. This column represents your objective function, which you're trying to maximize, and this is the maximum value of that objective function. Okay, so we can see that x1 is equal to 70. Oh, the maximum is 29,000 when x1 is equal to 70. x2 is equal to 40. x3 is, well, this is a non-basic column. It's a non-basic column, so x3 by default has to be 0. S1 is non-basic, so that has to be 0 by default. S2 is a basic column because I just see the 1, 1, and everything else is a 0. So S1 is going to have to be 40. Oh, sorry. I mean, no. Wait a minute. S1, S2, S3. S2 is 40. S2 is 40. S3, the S3 column is non-basic, which means S3 is going to have to be 0. And that is correct. So again, I have to emphasize this, guys. If you really understand chapter 4, then this chapter should not be that difficult. If you don't understand chapter 4 at all, this chapter could be extremely difficult for you. I will say this though, okay? If you're gonna go into, like most of you guys are gonna study business, accounting, finance, international business, marketing research and stuff like that. Guys, I'm sorry, but business, is full of mathematics, right? And if you want to get a business degree, you're gonna have to take some math courses, okay? There's just no way around it. You're gonna have to study some math. So that's, we will do more of these problems in future videos, but right now I do have to get going. Let me know if you need some help. I'll do what I can, okay? Take care and enjoy the rest of your day. Bye-bye.